Introduction to REST. REST stands for Representational State Transfer. It is proposed and originated by World Wide Web. It relies on stateless client-server protocol. REST is applied to connectors and data elements. It enhances induced performance, scalability, simplicity, modifiability, visibility, portability, and reliability. Background and history of REST. REST was first introduced by Roy Fielding in 2000. The HTTP 1.1 protocol and Uniform Resource Identifiers are both designed using REST. REST is developed to identify existing problems, to compare alternative solutions, and to ensure protocol extensions. It is built with a set of core constraints. Mobile application communicates with REST API version 3 and version 4 endpoints using HTTP or HTTPS secure protocol. REST API endpoints in turn communicate with Services API using named pipes for post-processing of requests and delivering corresponding response. Named pipes are used for inter-process communication between pipe server and one or more clients. It is generally a two-way duplex communication medium. This communication method provides a fast connection and in-memory service, which in turn minimizes the latency between two services. Service client or web client communicates directly with Services API using HTTP, HTTPS, or named pipe medium. The REST API requires a connection to the relativity engine or specified database, which is used to load configuration data. Features of REST. Client server. REST provides uniform interface separating clients from servers. It improves the portability of the client code. Servers are simpler and scalable. Stateless. While processing requests, client context is not stored on the server. The information required to service the request is contained in the request itself. Session state is held in the client. Cacheable. No client-server interactions are needed when the page is well managed and cached. The responses are cached by clients and intermediaries. Only implicit or explicit definition of responses should exist. Layered system. Layered system was designed as the client was not able to figure out if it is connected to the end server. System scalability is improved by enabling load balancing and by providing shared caches. Security policies are enforced in REST API. Code on demand. Servers can extend the functionality of a client by transferring the executable code. Compiled components like Java applets and client-side script such as JavaScript are examples of code on demand. Code on demand is an optional constraint in the architecture of REST. Uniform interface. It decouples and simplifies the architecture. Each part of uniform interfaces evolves independently. REST is applied to web services. HTTP-based RESTful APIs are categorized with the following aspects: base URI, and internet media type for the data, standard HTTP methods, hypertext links to reference related resources. It decouples and simplifies the architecture. Each part of uniform interface evolves independently. Architectural properties of REST are performance, component interaction to be dominant for user-perceived performance, and network efficiency, scalability, for supporting many components and interaction among components. Simplicity of interfaces is induced. Modifiability of components to meet the changing needs. Visibility of communication to process the component by service agents. Portability of component to move the program code with the data. REST services in various technologies. REST can be used in many languages regardless of the technology used by the consumer developer. The languages in which REST can be used are .NET or C#, Java, Perl, Cold Fusion, Node or JavaScript, ActionScript, PHP, Python, Ruby. Ways in which we can implement REST are by sending HTTP GET or POST requests in each language, by calling HTTP client request, using AJAX, JSON, and asynchronous JavaScript calls, invoking directly from a web browser in case of GET request, calling from third-party API simulators like Postman API, RESTful API description languages. These languages are designed to provide a structured description of RESTful API that is useful for human beings as well as automated machine processing. It is also known as Interface Description Languages or IDLS. Structured description is used in IDLS to generate documentation for human programmers. List of RESTful APIs are WSDL or Web Services Description Language, WADL or Web Application Description Language, CloudRail, API Blueprint, IODocs, Apache Avro. List of RESTful APIs are RAML or RESTful API Modeling Language, Hypermedia, Google Cloud Endpoints, OData or Open Data Protocol, Swagger, RSDL or RESTful Services Description Language.